Good day, everyone. We are the group 3 and we will be discussing our topic today by describing the individual performance and relationships. In addition with that, we will give examples to further understand the discussion. So first off, we are going to discuss the describing individual performance and its different kinds of converted scores. So the procedures for converting raw scores to standard scores are presented in this video. So there are four standard scores, which are the Z-score, T-score, standard 9 or STAN 9, and lastly the percentile ranks. So the first one is the Z-score. So by the way, I will no longer read what's in the slide. I'll just go with explanation. So the Z-score is usually very useful in comparing a student's performance in different subjects or tests, or in comparing two students from different groups. And in this slide, you can see we have here a z-score formula where z is the z-score, x is the raw score, the sample mean is the mean, and s is the standard deviation. So second is the t-score. It enables you to take an individual score and transform it into a standardized form one, which helps you to compare scores. So we have here a t-score formula, and remember, in computing t-score, we have to convert the raw score to z-score, then use the formula, which is the t-score equals 10z plus 50. And the third one is the standard 9 or STAN 9 is a score and a way on a 9-point scale. It can be used to convert any test score to a single digit score. So we have here a standard 9 or STAN 9-point scale where the graph that follows shows the basics of how to analyze STAN 9 results. So as you can see, this is a 9-point grading scale with 1 being the lowest and 9 being the highest. So this is said to be easier to understand among other standard score models where it can be interpreted as follows. The STAN 9s 1, 2, and 3 are below average. STAN 9s 4, 5, 6 are average. And STAN 9, 7, 8, 9 are above average. So the graph that follows shows how to analyze STAN 9 results, which is this table. It summarizes the interpretation for ratings from 1 to 9. So, when assigning grades using STAN 9, first we have to arrange the student scores from lowest to highest. So, as you can see, the lowest 4% will receive a rating of 1, describes as very poor, and meanwhile, the highest 4% will receive a rating of 9 and described as very superior. So the lastly, the percentile rank is typically defined as the proportion of scores in a distribution that a specific score is greater than or equal to. So conversely, percentile rankings are usually utilized in entrance examination results for some state universities and colleges when allowing only one specific percentage of takers to enroll in their institutions. So nonetheless, we still need the deeper knowledge to understand these four types of standard scores: the Z-score, T-score, standard 9, and percentile ranks. So therefore, let's proceed to the next presentation.
Let us proceed on how to get the z-score. And this is the first example. So a test score of a student is 90, and the mean of the test scores is 50, and a standard deviation of 15. Now, assuming that the distribution is normal, what will be the equivalent z-score? Now, we will figure this out. Now, these are the given. The x here is the test score of a student 90, and the mean of this test score is 50, the standard deviation of 15. X minus x divided by SD. So, 90 minus 50 divided by 15. So 90 minus 50 equals to 40 divided by 15. The total is 2.67, which means this 2.67 is the equivalent z-score.
So, good afternoon everyone. In continuation of the report, I will be going to discuss on how are we going to get the t-score from the z-score. So, here are some example. It is already given the z-score here, 1.43. So, the formula of the t-score is t equals 10z plus 50. So, t equals 10 times 1.43 the z-score plus 50. So the t-score of the t-score is 64.3. It is above average. So here are some examples too. There are given set of values. So on how are you going to get the t-score? So as you can see already, it is given the z-score here. So to calculate the t-score, we use the formula t. So the number one, the number one example is to calculate the t-score of the Filipino subject. T equals 10 times negative 1, which is the z-score plus 50. So the t-score is 40. It is below average. So for the English, we already used the formula. T equals 10 times 2 plus 50. So the t-score is 70.
Getting stand-in. In getting standard 9, we may have to observe these graphs. Remember that standard deviation will define what description where it belongs. These are the standard deviation. Remember that. I have an example here. Jerry tested considerably above average. Now, the graph below shows that the stand-in percentage of scores and the description. Jerry tested considerably above average. Therefore, if we follow his percentage score is 12% here and was in the 7th stand-in. Therefore, his score was in 7th stand-in.
Now let's discuss the percentile rank and its example. So this is the percentile formula and this is the example. We're going to find out the percentile rank of score 71 with a given number of lowest scores, which is 6, and the number of items, which is 10. Therefore, the result of 71 score is in the 60th percentile. So this is the formula on how are we going to identify the rank of the percentile. So this is the example, the same scores example. And now let's find out the 60th percentile rank, which result to the rank of 6.6. However, there isn't 6.6 ranking ever heard in high school. Therefore, you're going to round off or round down. So 6.6 is closer to 7 than 6. I'm going to round off the 6.6 to 7. So the rank of 7, which is in the 60th percentile, and we're going to count it from left to right, which result to the score of 71.
Good day everyone. So let us tackle about describing relationship about correlation coefficient. Correlation is a statistical technique used to show if there exists a relation between two sets of data and how strong this relation is. This is represented by a correlation coefficient or R value whereby person-product moment correlation is the most widely used formula for calculating it. This coefficient has values ranging from negative 1.0 to positive 1.0. The closer the value of R to negative 1.0 or positive 1.0, the stronger the relationship between the two data sets. However, an R value of 0 means that there is no significant relationship between them. So, the correlation coefficient can have three possible results: positive, negative, or zero. If R is positive, this means that as one variable or dataset increases, the other dataset also increases. Conversely, when one decreases, then other will decrease. For example, high performance in mathematics is associated with high performance in English. So, in a general sample, there will be a positive correlation between low creativity and intelligence scores, but a correlation will not be found with higher scores. Lower creativity is usually linked with low intelligence scores. However, high intelligence scores could have a range of creativity. It captures the strength and direction of the linear association between two continuous variables. It tries to draw the line of best fit through the data points of two variables. Pearson correlation coefficient indicates how far these data points are away from the line of best fit. The relationship is linear only when the change in one variable is proportional to the change in another variable. So therefore, let's proceed to the next reporter.
Describing relationship between correlation coefficient. So correlation coefficients are used to measure how strong a relationship is between two variables. It is also called the rank correlation coefficient, and linear analysis is carried out with the help of the rank of the variables. This coefficient does not require the analysis of original variables to meet specific requirements. So just like the other one said, that one indicates a strong positive relationship, while negative one indicates a strong negative relationship. And the zero result indicates no relationship at all. So the absolute value of the correlation coefficients give us the relationship strength. So the larger the number, the stronger the relationship.
Describe relationship about correlation coefficient. Example of correlation. For example, if a company wants to use a test to select salespeople, the correlation of scores on the test with sales figure. The criterion is criterion-related evidence of the validity. The formula in 7 shows in the correlation of the longer test as a function of the number of parallel measurements. The correlation of each of these measurements with the criterion variable and the reliability coefficient for each of the parallel measurements. Lengthening the test increases the correlation with the criterion. Another example, the sample is of size t with homogeneous space observations. Correlations values are unitless and may range from one completely anti-correlated to one completely correlated. A value of 0 indicates two uncorrected series. The simple means and have to be reconsidered. In equation 10.5 in the special case of risk assessment, we can still replace them by 0. Otherwise, we prefer that they are calculated again in a weight fashion so that returns are considered only when observations over intervals of size exist. So data sample also used for the rest of the correlation calculation, the weights adjust for periods of lower or higher activity.